కదా ఇదే కదా కరెక్ట్. ఓకే ఓకే రైట్. ఓకే, వెల్కమ్ టు MyDG Temple of Learning, my dearest. Now we are taking the structural analysis, get through questions. First we are taking the method of joints. On method of joints and method of sections, how the problems are likely to come. Okay, first question is, for the truss shown in figure, the number of members having zero force. To find the members having zero force, we have four methods. I have told you we have discussed about the four methods. There are four ways of detecting members having zero force. First method is at a joint. At a joint, if two non-collinear members are meeting with no external load at that joint, then force in both members are zero. This is one thing. Another one is at a joint, if three members are meeting, two members are collinear, force in the third member is zero. Next, third one is about the panel shear. Some loads are there like this, let us assume. Some loads W1, W2, if loads are there. Similar to the beam shear, we have a panel shear in the first panel, second panel, like that. If panel shear force is zero in any panel, then force in the inclined member in that panel is zero. That is third way. Then fourth way is, if at all deformation in any member, if deformation is impossible, it means that force in the member is also zero. That is because of this one. Force in any member is nothing but AE by L into delta. If deformation delta is zero, force has to be zero. Okay, this on these concepts, let us see how to get how many members have zero force in this problem. Now, first take this one. At E, there are two non-collinear members, no external load. So this is zero, this is zero. Now if we take joint B, there are three members, two members are collinear, force in the third member is zero. Next, panel shear. Take a section here. Panel shear, stand here, look one side. There is 20 kilonewton. Since that means stand here, look one side. If panel shear force here is 20, that means force in this member is not zero. Take this panel, look up. 20 right side, 20 left side. Net force is zero. Then force in the inclined member in this panel is zero. So force this has to be zero. Then stand here, look above. 20-20 got balanced. So force in this member has to be zero. Next, coming to this one at C. 1, 2, this already zero now. 1, 2, 3, 2 are in line, third must be zero. That is the third way. Panel shear also now we have checked. Next, in any member, if deformation is impossible, we have to see. Take force in the member AH. Both supports are hinge supports. So AH member cannot elongate or contract. So which means that force in the member AH is also zero. Deformation is zero, so force in the member AH is zero. Two non-collinear members, no external load, force in these two members are 0. Three members are there, two are collinear, so force in the third member is 0. Panel shear is 0 here and here, so these two became 0. After they become 0, now come to C. 1, 2, 3 it will be there. So 2 are collinear, third has to be 0. So now total number of members having 0 force are 1, 2, 3, 4, 5, 6, 7. So in 2 minutes time, so this is the answer. Okay. Next. We're sorry, our questions were deleted. Now I write the question also. So what is the force in the member BC of the truss? BC of truss shown in figure, caused by lifting the 120 kilonewton force. One 120 kilonewton load at a constant velocity of 3 meters per second. We have a roller support here. This point, let us say A, B. This point is say C. And here we have a pulley. And here it is D. This is 120 kilonewton. A rope is passing through this one and you are pulling with a force P. Okay. So this is actually a pulley. These lengths are 4 meters. This is 3 meters. And the slope is also given, slope of this load. This is 3, 4. Okay, this is a problem. What is the force in the member BC of the truss shown in figure, caused by lifting the load 120 kilonewton at a constant velocity of 3 meters per second? Okay. Constant velocity means acceleration is 0. That means it is in equilibrium only. So acceleration is 0 means it is in equilibrium. A body will be in equilibrium which is at rest or which is moving with a constant velocity. So it is moving downward with some constant velocity of 3 meters per second. So acceleration is 0. That means it is in equilibrium. This is a pulley. Okay. That means your P also must be 120 kilonewton. If they don't mention anything about the friction, belt friction is not there, we have to assume. So belt friction is not there, so that means it's a smooth pulley. So 120 kilonewton down, but this is also downward 120 kilonewton. Now what is the force in the member BC? These are the options. Let us say 120 kilonewton tension, 120 kilonewton compression, we have 192 kilonewton tension, 192 kilonewton compression. Now, this is a problem. Now, we are not interested in the pulley. So, what pulley does on the truss we have to show. So, for that we require what is the free body diagram of the pulley. So, this is our pulley. This is 120 kilonewton. Here also the force in this direction is P is 120 kilonewton. This is 3, 4. This value some theta. This is some C. So, free body diagram of the pulley means on the pulley what others are doing we have to show. Now, pulley is connected to the pin at C. So, what pin will do on this one is, for this pulley to remain in position in the truss, what the pin will have to do is, it will have to exert one upward reaction VC, then horizontal reaction HC. VC and HC are the forces exerted by the pin on the pulley. So, this is your free body diagram of pulley. Now, if you write sigma y is equal to 0, by taking upward forces positive, downward forces negative. So, minus 120 sin theta plus VC is equal to 0. Sin theta means how much is that? 3, 4, this is 5 will get. Sin theta is 3 by 5, that means 0.6. So, this value will get 0.6. So, 72. So, VC you will get 192 kilonewton. HC value also we will get, but we are not interested in that HC. Now, if you show here the free body diagram, in this one, now what this is VC, HC are the forces exerted by the truss on the pulley. In return, what pulley will do on this one is, this is now net force. This force now is 192 kilonewton. Horizontally, here it is right side. Here it is exerting left side. Now here it should exert right side. Some force HC. But this force we are not interested, because they are taken by the AC and CD member. If this is 192 down, here 192 up, arrow mark away from the joint, away from the joint. So now this is force in the member BC. From sigma y is equal to 0, it has to be 192 kilonewton. Arrow marks are away from the joint, that means it is tension. So this is a process. What here yellow color ones VC, HC are shown is forces exerted by the truss on the pulley. In return, what pulley will do on the truss is, it will exert a opposite to this one. VC is down, HC is exerting left side, here it will exert right side. HC we are not interested, we are interested only in the force BC. So because of the pulley, there is a net downward force at the joint C of 192 kilonewton. So to resist the downward force, this will be under tension, 192 kilonewton. Okay, so this is how we should manage the problem. So 192 kilonewton tension is the answer. So this is how we find force in the member BC. 192 kilonewton. So for that we required free body diagram of pulley. Done. I think this much time is sufficient for us. Next one. Okay. Force in the member CD. Okay. Okay. This is a roller support. This is a B. This is C, where you are applying a load of say 60 kilonewton. This is a D, E, and this is F. This is our problem. These are the distances. They have to give us these distances. And here also these distances. Okay. From here to here, let us say this is 2 meters, 4 meters, 2 meters. This is 1 meter. Okay. Is a 2 marks question. Options will be given as say 0, say something like that they have given. We want to find force in the member CD. Okay, first we'll try. What we have done was, first we'll check method of joints. If there is any joint where only 2 unknowns are available, we can take that joint and find force in the those 2 members and proceed to the other joints. So which joint has only 2 members? You see, any joint you take it, all of them have a minimum of 3 members. So directly method of joints we cannot apply. Now method of sections. If I cut like this, 1, 2, 3, 4, 5 members are cut. If I cut like this, 1, 2, 3, 4 are cut. So whatever way you are cutting and separating the truss, you will get at least a minimum of 4 members are getting cut. Such cases, what we do is, okay, first we'll try to find the method of joints and method of sections in its direct form. It looks minimum, as we have learned that don't cut more than 3 members. If you have to cut more than 3 members, the unwanted members should meet at one point or they should not come into picture. That's what method of sections we have studied. Now first we'll try to find the support reactions for this one. This is VA, WB by L, that means 60 into 4 by 6. So you will get 40 kilonewton. F is 20 kilonewton. This is WA by L. That means W is 60, A is 2 by 6. 20, this is WB by L. That means 60 into 4 by 6. 40 kilonewton. Now, I want to use method of sections, and by inspection we have to complete the problem. So what we do is, we will cut it like this. So this part we are cutting. Why? Our wish to cut the way we like. In the process, if I take this free body diagram of segment ADE, so we are, that green color line is our cut. This is how we are cutting it. So how many members got cut? AB. BF member is getting cut at two places. Let it be cut, no problem. Here and here it is cutting. We will show what they are doing. Supposing that this, since you are cutting this, what this is doing on this is force in the member BF. It's cutting here also. So towards joint means force in the member BF. I am cutting the same member BF at two locations. So, but the forces I have shown here and here, they get balanced. They don't come into picture at all. Take this one. What this will do on this, when I am taking this free body diagram means it is the diagram of a body on which what others are doing you have to show. So what this is doing on this one, we don't know. So let us say force in the member CF towards joint. So here also it is getting cut. So these two, we have cut them at two places, so they don't come into picture in any equilibrium equation. Now what this member will do, let us assume that it is doing, this member is exerting on this one like this. Force in the member EF. Now let us see what this is doing here. Let us say this member is compressing this one, force in the member AB. Now we are cutting this also. What this will do on this is, let us say force in the member CD. So on this free body diagram of ADE, we have cut here and here, here and here, so they don't come into picture. Means they, whatever equilibrium equation you take it, they will not come into picture. Now how many unknowns are there that will come into picture is FAB, FEF, FCD. FAB and FEF we don't want to find. Our interest in 2 minutes time is finding force in the member CD. Now you see AB is vertical, EF is vertical. I don't want them to come into the picture at all. So if I write sigma x is equal to 0, so these two vertical members, they will not have any x component. So they become 0. Means if I write sigma x 0, they will not have any effect on in the x direction. Only one force is there, so it has to be 0. So force in the member now CD has to be 0. This analysis is for 2 minutes time. First find reactions. I want force in the member CD, so you cut it like this. In the process of cutting that way, these two members are getting cut at two places, so sigma x, sigma y, sigma m, they don't come. Now another members that are cut is only 3. 1, 2, 3. Out of these 3, 2 are vertical. So if I write sigma x 0, this no influence. So FCD, this FAB and FEF in the sigma x direction, they will not come into picture. So FCD will become 0. So force in the member CD is 0. Now after finding force in the member CD 0, this value is 0. Now how many members are, this is over, question is over already. Now we wanted to just observe the other forces, how they look like. Now at D, how many forces are meeting? Once this is 0, this is two non-collinear members. No external load. at that joint. That means force in both members are also 0. Now come to E. Now only two members are there, two non-collinear members, no external load. That means force in these two members also will be 0. Okay? So like this. That means if these two are 0, if you have, this is 40 up, say, this is FAB will be 40 down. 40 kilonewton downward. So towards the joint. Now this will be accordingly towards the joint. This by you can take here sigma x0, sigma y0 to find these two forces. Then here sigma x0, sigma y0 to find these two forces also. But that much will not be there. Our task is only force in the member CD. Okay? Observe that how we have cut this dotted line is our cut. Okay? Now I think it's understood. How method of sections can be used, not necessarily a single line. Your cut section need not be vertical. It need not be inclined. It can be curved also. Whatever segment or whatever section of the truss you want, you can take it. You can plug that, stick it somewhere else, and in its isolation, it should be in equilibrium. Since the truss is in equilibrium, this part alone, if I take it, that also must be in equilibrium in its isolation, which means that FCD has to be 0, otherwise sigma x0 will not happen. So from sigma x0 point of view, it has to be 0. Okay, done. So this is about method of joints and method of sections. If at all they ask you a question like this, by inspection if you want to find, because you have only 2 minutes time, force in the member CD if they ask you. Other member forces we have solved in our regular classwork, method of sections, many problems we have already studied. So this is some other addition to that. Okay, now let us see the next one. And the deflections. We have used the Castigliano's theorem 2. This is C. The 4 outside members of this truss shown in figure have their temperatures lowered by an amount of 60 degrees centigrade. What is the change in distance? Distance between B and D. B and D. Take alpha, this they have to give us 12 into 10 to the power of minus 6 mm per degree centigrade. Outside members of the truss shown in figure have their temperatures lowered, means they will get contracted by an amount of 60 degrees, change in distance between B and D. All the problems got deleted, so we are writing again. Okay. Okay, now we have a hinge support here. We have a roller support. This point, let us say A, B, C and D. This length is 2 meters. Okay. They may give you the options like this. Okay. Now this is our question. We have the a truss is like this. The 4 outside members, that means in your table, 4 members must come. Of the truss shown in figure have their temperatures lowered by 60 degrees centigrade. All members have decrease in temperature by 60 degrees. What is the change in the distance B and D? That means because the temperatures are lowered, how much the B and D joints moved towards each other or away from each other? How much length changed means the relative displacement of B and D in the direction of BD. That is what we have to find in 2 minutes time. But 4 members are temperature lowered, but all members are equal length, same temperature. So only one line. You have 2 minutes time, can be completed in a maximum of say 30 or 40 seconds time. He is asking change in the distance between B and D. This is our solution. Delta BD. Change in distance between B and D. That means what? Relative displacement of joints B and D. Relative displacement of joints B and D. From the Castigliono's theorem 2, you can find displacement of joint, relative displacements of 2 joints, then rotation of any member. Now this is related to relative displacement of 2 joints B and D. Standard formula is PKL by AE. This we write it as, to save our time, that PL by AE values if they give K into delta. Now this delta, as per the Castigliono's theorem 2, will not vary the cause of this delta. If loads are applied, then PL by AE of each member, we have to keep it in that expression. If loads are not there, temperature changes are given, that PL by AE is replaced by alpha TL. Even if temperature changes are not there, fabrication errors are there. That means fabrication errors means if the length of the member is supposed to be say 2 meters, they are not able to cut it by 2 meters, there is an error of say 3 mm or 4 mm. So that also can be taken as the deformation. Either if it is in the fabrication error, if the a particular member is too short, then you can take it as contraction. If a particular member is fabricated 5 mm too long, then that we will take it as elongation. Like that. So in this expression, delta can be due to applied load, then PL by AE, can be due to temperature changes, then delta is alpha TL, or it can be fabrication error or lack of fit. So now delta we have to take for 4 members. So your first step should be delta values. Delta for AB, BC, CD and DA. All delta values are same. See here. AB, BC, CD, DA. What is the length? See here, if total length is 2 meters means from here to here 1 meter. Okay. 1, 1. This length is, each length is root 2 meters. So, we can write alpha TL if you put it for each member. Alpha is 12 into 10 to the power of minus 6 mm per degree centigrade. Temperature lowering 60 degrees centigrade. Now it is not necessary that always they have to increase the temperature in the exam, the questions. It can be lowered also. So alpha TL. Length is root 2 meters. Okay, we can write in terms of root 2 meters itself. We substitute, this is contraction. For all the members, delta values are same. This will take, say, 15 seconds we have taken. Next. What we require is K values. You must apply 2 unit loads at B and D. Here itself I will apply on those 2 values, or otherwise separate diagram also we can write it. Okay, we'll write those values separately. Second one, K values. This was a hinge support, and this is roller support. This is A, B, C and D. Okay. Let us assume that we do not know how whether they are moving towards each other or away from each other. Some direction we can assume. One here, one here. By writing 1 and 1, 2 unit loads, we are assuming that the joints B and D are moving towards each other. Now, we have learnt that any structure, any statically determinate structure, if it is subjected to a system of forces which are in equilibrium already, support reactions will not develop, because it is subjected to 2 forces which are already in equilibrium. Equilibrium forces which are already in equilibrium, you take them and stick them. Reaction supports will not react to that. That means your support reactions are 0. HA is 0, VA is 0 and VD is also 0. Now come to the member forces. We require only 4 member forces. AC member force we don't require because delta is not there. So finding the value of K is useless. I pull it down. When I hold this and pull it down, how these 2 members respond is in the upward direction. Like this. If arrow mark is towards the joint, here also towards joint, so towards the joint. Here up. So it has to be down, down to balance it. This arrow towards the joint, towards the joint, towards the joint. Next. If you take sigma x is equal to 0 consideration, this force and this force, AB has x component right side, BC x component left side. They have to be equal because theta is same. Forces must be same. This angle is 45 degrees. This also 45 degrees. Since angles are same, forces must be same. Otherwise, sigma x 0 will not happen. Next, y component you take. KBC sin 45 plus KBA sin 45 must be equal to 1. Sin 45 is 1 by root 2 plus 1 by root 2 means we will get 2 by root 2. That means root 2. Root 2 into KAB is equal to 1. So KAB is 1 by root 2. Force in this member now will become 1 by root 2. How? Assume that when I talked, some of you might have not understood what we were talking. Supposing that at B, if I write sigma y is equal to 0, KAB cos 45 plus KBC cos 45 upward, so minus 1 is equal to 0. Cos 45 is 1 by root 2. This is 1 by root 2. That means 2 by root 2. Root 2 times KAB is equal to 1, because KBC is also nothing but KAB. So KAB you will get 1 by root 2. Arrow mark is towards the joint. So compression. In the exam, as we used to discuss, this much we should not write to know why KAB is 1 by root 2. You should be able to read it. Because angles are same, forces must be same. From sigma x is equal to 0 point of view. Sigma y is 0. This is some f you take. F cos 45 plus f cos 45 is equal to 1. So 2f cos 45 is 1, means f must be 1 by root 2. Get it out? Like this. 1 by root 2 plus 1 by root 2. Both are same. So 2 by root 2. That means root 2 times KAB. So KAB is 1 by root 2. In the exam, this type of configurations only they will give us, so that we can, by seeing the diagram itself, we can get the values. Now, what is the direction of the force in the member AC? We don't have to find. Your next point is relative displacement of joints B and D. Summation of K into delta. Any one member you take, KAB into delta AB, because K values are same, everywhere it is same. See here, root 2 we have written. Because of symmetry, this has to be 1 by root 2. Here also, same configuration here also is there. So 1 by root 2, 1 by root 2. So 4 members forces are same. 4 members delta values are same. So now we can write 4 times into 4 I can write directly. 4 times KAB, compression. This is the sign convention, we will take it. Compression, negative. Corresponding contraction. This is the sign convention. Compression, contraction. You take it as negative. Tension, corresponding elongation. We take it as positive. So KAB is minus 1 by root 2 into delta AB. Alpha TL. 12 into 6, this directly will write it. 12 into this is because the delta AB is contraction. 4 we have taken, KAB is 1 by root 2 common. Alpha, this is 12 into 10 to the power of minus 6. Temperature change 60 degrees centigrade, length is root 2 into 1000 mm we can make it. So root 2 cancels out. So this value works out to be 2.88 mm. This is calculation, you can make it. Point is this much, 4 members, same K values, same delta values. So 4 members you can take it. This is contraction, so minus we take it. Negative because contraction. Why contraction? Temperature got lowered, so it will tend to contract. Here also KAB, why negative? Because compression. Okay, so 2.88 mm. Like that. So next one. I think I may have to show this one. This is the problem. 4 members are there, temperature lowered by 60 degrees. How much distance B and D distance changed? Means relative displacement he is asking. So change in the relative displacement means K delta values are same, K values are also same. Okay, now multiply them. Next, okay, slope at B. Let us say this moment 60 kilonewton meter, A, B, C. This length let us say 4 meters, I. This is say 2 meters, I. Options are like this, 0, 40 by EI radian. Now we want to find, let us see, all possible ways we'll discuss. If you have say only 5 seconds time, how to manage, or if you have more time, how to manage, let us see. When you apply say 60 kilonewton meter clockwise, what are the support reactions? Now first we should eliminate in our process of thinking that you may think that we should use MDM, moment distribution method. This 60 kilonewton meter, let me distribute in the ratio of their distribution factors. If we do that, the problem is that it will sway also, because roller is there, hinge is there. So due to non-sway moment analysis, you have to do it separately, sway analysis separately, it will take minimum 10 minutes time. So moment distribution method should not be used because of the sway. So MDM is ruled out. Next, to find the slope at B means it is a statically determinate structure. Hinge support, roller support. If you have a statically determinate frame or determinate truss or a determinate beam, then you must use Castigliano's theorem 2 or strain energy method. That is the best way to get out of the problems in our stipulated time. So we take the strain energy method. So what is that strain energy method is this one. That is, this is first observation. We'll move that. Don't use MDM due to sway of frame. Then use theta b is equal to integral of mx into m into dx by ei. This is the formula. That means if all possibilities, shall I use that way, shall I use this method, you take 15 seconds time, let that much time be wasted. Then you are sure that now this will take only 1 minute hardly to manage that. So mx means bending moment due to applied loading, m means bending moment due to unit moment applied at b, and multiply them. Let us see that both ways how we have to manage. First one is mx and m values. This I am assuming that if you have a time of say 1 minute time is there, you want to do it, you are doing like this. If 5 seconds only time is there, then we'll see how we have to manage this one. ABC, this is 4 meters, 2 meters. Then okay. One you have to apply, and it has no units. Now if you see the support reactions, this is a clockwise movement, so anti-clockwise couple must develop like this. VA is equal to and VC is equal to. What is the formula? Clockwise movement M, so anti-clockwise couple. You see how my fingers are moving down and up. So anti-clockwise. So VA is M by L, 60 by 2. 30 kilonewton down, 30 kilonewton up. Similarly, 1 clockwise. This is 2 meters, 4 meters. Clockwise, so it has to be 1 by 2. Upward 1 by 2. Then horizontal reaction, now it has to be 0. Here also same. A, B, C. Okay. Now mx and m values will find it. Take a section xx here at a distance of x. Here also same. Take a section xx at a distance of x. Wherever you take a section x here and here, same place here also we have to take it. This is at a distance of x. At a distance of x. So this is mx values. Let us call it as mx diagram. This is small m diagram. Now you see. This is first point. Then second point is your mx and m values. When you have written that theta b is equal to integral of mx into m into dx by ei. If you have to deal with two members, you will have to write table. First mx values, m values, then integration. See here that two members requirement is not there. To find the moment, you stand here. To decide whether a particular force gives you sagging moment or hugging moment, stand here, look this side. Now if you stand here, look left side. This VA is 30 kilonewton is there, HA is 0. That means bending moment at XX is 0. If MX is 0, that means the contribution of the member AB to theta B is nil. So I don't have to write that because MX value is 0. Now stand here, look right side. Upward forces will give positive moment. So 30 into X. This is half into X. Only one line. Integral of mx. As we have taken, only one member you have to take. 30 into x. Mx into m. M is what? Stand here, look right side. Half into x. Upward forces will give positive moment. Mx into m into dx by ei. What are the limits of integration is 0 to 2 meters. So 15 into x square means x cube by 3. That means 2 cube by 3 ei. So 3 5, 8 into 5, 40. 40 by ei radian. See, that's all. First, quickly we'll write mx and m diagrams. Find the support reactions. The support reactions will be such that by inspection itself we will be able to find the support reactions. So find them. Generally these values, maximum is 2 members, you have to write it. Otherwise, if they want to save your time, only one member. Okay, so only one member, 0 to 2 mx m dx by ei. 40 by ei radian. Observe this one. This member, AB member, is not taking any moment at all. Wherever you take that moment in the member, AB is 0. Your entire moment 60 is taken by BC member only. Right? If you visualize by inspection how to complete in say 5-10 seconds time if you want it, apply 60 kilonewton meter. Due to 60, anti-clockwise couple will develop, reaction is 0. That means bending moment is 0 in this member. Then who will take 60? BC member only will take. Now I can write this one this way. Whatever way it sways, this point is A. You are applying this is 60. B. This is C. Now entire moment is taken by BC only. Now the deflection profile will go something like this. AB member will remain straight because bending moment in the member AB is 0. But BC member has to bend. To accommodate that slope, this vertical member will rotate so that 90-degree angle will be maintained. Like this. C will go to C dash. Now see, this profile is a known profile for us. Okay, this slope is now theta, B is the question. Moment is 60. This is a known profile for us. For this profile, when far end is hinged, when you apply moment 60, what is the formula? ML by 3EI. M is 60, length is 2 meters by 3EI. If you have say only 5 or 10 seconds time, that mx mdx by ei, we don't have to write it. Just you understand from this diagram that when I apply 60, horizontal reaction is 0. That means AB member will not take any moment. That means 60 will be taken by exclusively by BC member. Rotate it. Then that profile we know. For that profile, slope also we know formula. In MDM we have studied ML by 3A. This formula, strength of materials, I think you might have already studied. This slope is ML by 3A, far end is ML by 6EI. So 40 by EI, you check that one of the answer will match with that. 40 by EI. That's all. Supposing that idea doesn't strike you, then we have to spend 1 full minute time. This one. First thing is don't use MDM. Second thing is MX MDX by EI. Check if you can further save time. Even if you do this way also, it doesn't waste much of that, but to that extent 40-50 seconds time. But those who could guess AB will not contribute to rotation of the member AB. Directly by inspection you can get ML by 3EI. Fine. So when you stand here means here also you have to stand here only. Stand here, look this side. To decide whether this will sag or hog forces, look this side. Why like that? Already you have learnt in strength of materials some sign conventions for bending moment. To satisfy that sign convention, stand within the frame. Like that. Next. Fine. This is second step. Right? Only one member. Second member, by inspection you could find that contribution was not there. So you don't have to write a table and waste the time. The table, etc. for the beginners. Then now, this is only overall view I have given. Next. Next question, let us see. Horizontal displacement of joint B, delta HB. Okay. This point, let us say A, B, C, L, I, length L, I. I am applying some load P. Again, we will not try to use that MDM because it is swaying. And also it is statically determinate frame, one end hinge, one end roller. So we must use Castigliano's theorem 2 only. Okay? So options will be given to us. PL cube by 3EI. Six EI. Okay. We have say 2 minutes time to find what is the horizontal displacement of joint B. First, mx and m values. mx into m into dx by ei. Okay. Now mx values. This point, let us say A, B, C. Length is L, L. A, B, C. Now we have to apply only one. And it has no units. That's what we use in the Castiglione's theorem 2R strain energy method. Now you see, by inspection itself, all the support reactions, etc., we must manage. We should not write sigma x0, sigma y0, sigma m0 and find the values. See here, this P is right side, that means it has to be left side. Now white and yellow is forming a clockwise couple, P into L, clockwise. So to balance it, anti-clockwise. How much? VA is P, VC also must be P. So now anti-clockwise couple is P into L, clockwise couple is P into L. Equilibrium, one right, one left, clockwise. So to balance it, one down, one up. Okay. Now take a sections wherever you want. Whichever side is easier. Take a section XX at a distance of x. Here, take a section XX at a distance of x. Now you see, both members are contributing to the horizontal displacement of joint B because moment is developed here. Moment is developed here. Like that. This is section XX at a distance of x. Here also the same. Section XX at a distance of x. Okay. Now you have to find how many table. First we have to see. We have to stand here. Stand here. Stand here, look right side. How much is the moment? P into x. Here 1 into x. Stand here. What's the moment? P into x. Stand here 1 into x. That means both segments of the frame bending moment at x6 is the same for both the values. So two lines also we don't have to write and waste the time because both of the both members contribution is same. Mx values are same, small m values are same. So why to write to two times that also? So only one time we will write. Horizontal displacement of B. Integral of mx. Mx. P into x. Mx is P into x. M is 1 into x into dx by EI. If they don't mention about the nature of EI, we will assume that it is constant. So we will get P into, like this, how many segments are there? Two segments are there. Why two? Two members are there, same mx m values. So 2 into, see here, P into x square. X square integration is x cube by 3. Limit is L. That means P into L cube by 3 EI. That's it. So you will get 2 PL cube by 3 EI. Okay. 2 PL cube by 3 EI. Like this. So this is the task. There is a problem. This is the solution. Only one line. Means only one member. That whatever contribution is there, multiply by 2. So 2 PL cube by 3 EI is the answer. Next. Move up. I think this is now clear. We'll take up next one. Horizontal displacement of joint B. We'll take a semicircular beam. This point, let us say A, B, C. Okay. Now, first thing that we have to understand is it is not an arch. The difference between arch and a curved beam is horizontal thrust. If here also there is a hinge support, suppose, then when you apply load here, then thrust will develop, then arch action comes into picture. If that thrust becomes 0, it's simply a curved beam, that's all, or curved frame, whatever way you want to take it. And it is a statically determinate structure. One end hinge, one end is roller. Then you must immediately get the idea that I have to use the mx into m dx by EI. Right? So, these values first option may be 0. If you think that it is symmetrical, then you may think that B will not move at all. Then first option will be, that's why 0 will be there. Then you will get like this. So now our task is this one. Integral of mx into m into ds we have to write. Whenever you are dealing with a curved members or curved elements, instead of dx, ds must be there, because strain energy stored in the curved member only we have to consider. Okay, here also only half segment you consider, other half is also same, so just multiply by 2. Right? This is mx, here itself we will write it instead of taking a separate diagram. This is our problem. Horizontal displacement of B we want to find. Okay. We have to apply 1. This point, let us say A, B, C. Okay. We can take a section here. Already it is there. This radius R. This angle you can take say theta. This element is d theta. This is a curved element. Okay. Now the support reactions are Vb is equal to P by 2. Va is also P by 2. Here. There's no horizontal reaction here. From the load's point of view, it looks as if symmetrically loaded, but structure is not symmetrical. One hinge is there, here roller is there. So when you apply load, the roller rolls out. It tries to get flattened out. So that's why B will move. If at all hinge support also is there here, then structure is symmetrical, loading is symmetrical, we can tell. Then displacement of joints A and B will be 0. Now displacement of B is not 0 because the structure is not symmetrical. Now one right, here one left. No reactions here because this one and this one is not forming any couple. So they are in equilibrium. One right you have applied, so reaction developed, and couple didn't develop because of that, because those two forces are in the same line. So naturally Va has to be 0. Vb also has to be 0. Now this is the section XX we are taking at a distance of x. Here also same thing. Section XX at a distance of x, and this distance is y. This point let us say O, this is R, this angle is theta. Y value is R sin theta. What is x value here? From here to here it is R. R minus, if you take here, this is theta, this is R. From here to here it is R cos theta. So you will get R minus R cos theta, x value. Now we will find mx. Mx is equal to plus P by 2 into x. X means R minus R cos theta, small m, there. So what will get 1 into y. Sagging section right side anticlockwise, sagging section right side anticlockwise, sagging. So 1 into R sin theta. R sin theta. Then ds. Where is ds here? This one. This curved element. ds is r into d theta. Now here also, because of the symmetry of the only way as far as the loading is concerned, so only one element multiplied by 2. Integral of mx into m into ds by ei. So two segments are there, 0 to pi by 2, another pi by 2. 0 to pi directly we cannot take it, because 0 to pi same bending moment expression is not valid. 0 to pi by 2, whatever expression is valid, such segments are there 2. So 2 times 0 to pi by 2, mx is, or if you take common factor, pr by 2 into 1 minus cos theta into here r sin theta into ds is r d theta divided by ei. So you will get 2 to cancels out, pr cube by ei. So integral of sin theta d theta, this is 0 to pi by 2, here minus 0 to pi by 2 sin theta cos theta. Sin theta cos theta we know how to write. Sin 2 theta is 2 sin theta cos theta, so by 2 we will write it. So now pr cube by ei, integral of sin theta means minus cos theta, limits of integration 0 to pi by 2 minus sin 2 theta means cos 2 theta minus cos 2 theta by 2, but already 2 is there. Then limits of integration are here, this is also 0 to pi by 2. So you will get 1 by 2 is that value, pr cube by 2 ei. Like this. I think this is only integration process. You only have to be careful about this part. Remaining thing is like repetition. So what is answer? pr cube by 2 ei. Okay, like that. So in the frames or trusses, if they ask you deflections, they have to be statically determinate structures only. And for determinate structures only, beams or frames, we can use Castigliano's theorem too. If it is not not a determinate structure, then you have to take moment distribution method or slope deflection method, because that will let you complete the problems fast if it is indeterminate. I think this ones will have to like this. So on the problem itself we have written mx diagram, small m diagram. One example I have explained, so it is similar to that. Okay, now I lift it up. This is a simple solution only. Core part is only this much. Okay. Now we have a special class of structures called cables. I told we have known Done. We'll manage with this one. Now let us see a special class of structures I told you about, the cables. The cables can only take tension and compression, can only take only tension, no compression, no bending moment. So those structures, analysis of cables, wherever there is a cable involved, we have only two concepts: how to keep two forces in equilibrium and how to keep three forces in equilibrium. To keep two forces in equilibrium, we have learnt that they must be equal, oppositely directed and collinear in action. That is one thing. Then how to keep three forces in equilibrium? Those three forces, if you want to keep it in equilibrium, they must be coplanar and concurrent. So only two concepts are there. Those concepts how to use in the exam in 2 minutes time. Let us see how the questions will be asked on that. A bar of weight W and length L is resting against a smooth vertical wall. It is a smooth vertical wall and supported by a cable. Once you see the cable, then your task is simplified. That how to keep two forces in equilibrium, how to keep three forces in equilibrium. By a cable of length A as shown in figure. What is the value of X? X at which the bar will be in equilibrium. Okay. or otherwise directly we can show here itself A. Yes, this is the question. Cable. Sorry, the problems that we have written, they were somehow we couldn't find them again. So this is our problem. We have a bar of weight W. This AB bar is there. It is a smooth vertical wall. It is simply resting on that. Smooth wall. Okay. AB bar is resting against a smooth vertical wall means what? If you have a smooth vertical wall, how many reactions it will give? Only one reaction. Normal to the surface, not normal to the bar, normal to the surface. Then this is a cable. And this distance x. At what value of x this bar AB is in equilibrium? So 4 options, we have 2 minutes time. What we have to do is that whenever you are dealing with the cables, see here, on the bar AB, there is one, now this is the solution what I am giving. In 2 minutes time, what you are expected to do? So it will develop one horizontal reaction only, HA. HA is the force exerted by the wall on the bar. Next, cut the cable. If you cut the cable, it will fall down. Now it is not falling down, means if I cut here, this is the tension in the cable. Next, weight. The weight of this bar, the tension in the cable, HA. They are meeting somewhere here, some point O, let us say, supposing that. Then this weight W has no choice. This point, let us say some O. A is from here to here. Okay. Now this is O. This is the CG of the bar. Weight will act downward this way. Now if you see the free body diagram of AB, AB is acted upon by 3 forces, HA, W, T. To keep these 3 forces in equilibrium, they have to be concurrent. That means they must meet at one point. So line of action of T is already predefined. HA is predefined. When they meet, when you intersect, they have to intersect on the cable only somewhere at O. Then through O only weight must pass. Otherwise, the bar will not be in equilibrium. Only at that particular instant it will be in equilibrium. For any other position it becomes unstable. Now how to solve this problem? Now extend this line. This point, let us say D. Okay. Now this point A, B, C, D, let us call it as a some E. E is the midpoint of AB. So necessarily O, now if I take the triangle CDB and ABD, it is a midpoint, means when I draw vertical line here, this and this, they intersect at equal length, right? Then another triangle BDC you take, say, then when I extend this line, O also will intersect the line BC. It has to intersect. That means if this is X, this length, it doesn't have any choice. It has to be X now. In the exam in 2 minutes time, your task is to connect them then you should understand that because E is the midpoint, O is the midpoint, A is the midpoint of CD. If this is X, this has to be X. Now take the triangles. From triangle CDB, what I can write? BD square is equal to this is A square minus Pythagoras principle. BD square is equal to hypotenuse square minus other side square. So you will get A square minus 4x square. Next, from the triangle ABD, what I can write? BD square is equal to AB square. AB square is nothing but L square minus X square. I can write BD square is equal to AB is L square minus X square is BD square. From this triangle, A square is equal to 2x square plus BD square. So equate both. Equating 1 and 2. A square minus 4x square is equal to L square minus X square. Push it to the right side. So 3x square is equal to A square minus L square. So x is equal to square root of A square minus L square by 3. That's all. X value, at this value only the bar will be in equilibrium. Root of A square minus L square by 3. A square minus L square by 3 means this one. So we have learned many such problems, how to keep 3 forces in equilibrium, how to keep 2 forces in equilibrium. This is one additional problem to the already existing problems. Okay, now let us push it down. Okay, that's all. One line problem only. This is equal to this. Only this triangle you take it, get a relationship between X, A, L. Okay, next. That's it. Okay, next question we'll see. On the stiffness matrix method, for the frame shown in figure, stiffness matrix with respect to coordinate system. With respect to coordinate system is, to save our time, they will give us the stiffness matrix 24 EI by L cube 1 minus 1 minus 1 2. What is the horizontal displacement of joint A? horizontal displacement of joint A. Okay. This point, let us say A. Here the load, let us assume that 48 kilonewton. (96 kilonewton). This is A, B, C, D, E, F. This flexural rigidity, let us assume that it is infinity. Lengths of these members are L and L. This is coordinate 1, coordinate 2. So these coordinate numbers they will give, loads they will give, EA infinity corresponding to these coordinates, stiffness matrix also they will give us, because you have only 1 minute time to solve the problems. Right? Now, stiffness matrix once they give you, what does that imply is, when you apply unit displacement, what is the force induced or what is the force developed at the coordinate 1 and 2 because of the unit displacement. These forces are because of the unit displacement. I am not applying the unit displacements. I am not applying a K force. I am applying 4896 kilonewton. Then what is the displacement? If one biscuit is 10 rupees, two biscuits how much? Like that. That much concept only they have to ask us in 2 minutes time. This is the process. Solution. P values. They have given. How much force we are applying, they have given. K values. K value is what? Force required to produce unit displacement. But unit displacement will not happen. For unit displacement, K is the force. For delta displacement, K into delta is the force. That K into delta force they have given at coordinates 1 and 2. Now P means P1 and P2, forces applied at the coordinates 1 and 2. P1 we have applied, see here, how much is P1? Coordinate 1, 48, this is 96. This is 48, 96. Delta K also he has given, so you have to find only delta. Time is 2 minutes. So delta means delta 1, delta 2. Displacement at coordinate 1, displacement at coordinate 2. At coordinate 2, displacements you don't have to find, he didn't ask us, only one. So K inverse P. K inverse P. So that's it. K inverse means, inverse of we know how to find. So L cube by 24 EI. And the determinant of that matrix, how much is that? 2 in minus 1. 2 minus 1. Then what we have to do? Elements. Interchange the elements. 2, 1 plus 1 plus 1 it will become. Here 2, 1, here plus 1, plus 1. K inverse P. P values also we have known. What is the p-value? 4896. Here we have written 4896. Now you see delta 1 is nothing but displacement of A in x direction. You will get L cube by 24AI. This is 2 into 48 plus 96. Multiplication. So you will get 24 into 8. So 8 L cube by EI. That's all. Delta 2x if you, delta 2 if you want, then this and this you have to multiply. That we know. So this is the answer. 8 L cube by EI. Okay. See the scope. They give you, this is one way of asking the problem, finding the displacement if K they give you. Second way is, what is the stiffness matrix itself or only one coefficient? In the GATE, asking more than one stiffness coefficient, they didn't exceed till now. But just in case, if they want to ask like this, it won't take more than 1 minute time. It's just inversion of the matrix. That inversion also a 2 by 2 matrix only will be given. Okay, K is given, loads are given, displacement you have to find. So in 2 minutes time, K inverse P, we have to write it. So K inverse P is the problem. That's it. Okay. Now let us see how the questions will come on moment distribution method. See, moment at A. Okay. Let us say this load value is 16 kilonewton. This is 2 meters, 4 meters I, B, C. We have a frame A, B, C, D. At B it is not a rigid joint, it is a hinge. So if you want to find moment at A, finding the sum of the fixed end moments at B, MBA, MFBA, MFBC, MFC, BD, we cannot write and distribute. The distribution factors, which we have studied in MDM. What is the distribution factor? Distribution factor means it is the ratio in which the applied moment is shared by the members meeting at a rigid joint only. If there is a rigid joint means if you apply moment, all will share your applied moment. But if there is a pin, when you apply moment there, then question of distributing the moments will not arise. When you apply moment, that pin, whatever you provide there, it will rotate like a shaft. It will not transfer moment to any member. So what we would do that? what we have to do is first fix it. Symbolically you fix it. Then release it. Independently we have to release BA, BC and BD. Right? Independently when you release it, then moment at A you will get it. That is one way, independently releasing the moments. If you have only 10 seconds time, invigilators are pulling the paper, you have to answer that say. Then joint B will not come down or move right. What is the deflection profile of this one? Like this. This deflection profile is looking like a propped cantilever deflection profile. Now this B cannot go down, move right, it cannot move. So for a propped cantilever beam, we know how much we have to get the values. This is like this. This is what we have studied in your strength of materials also. Okay, this is what we have learnt. You apply some load W, let us say L by 2, L by 2, A, B. This profile is like this. For this profile, this VB we have learnt 5W by 16. Moment at A also we know 3WL by 16. Same thing we have studied in the plastic analysis also when you are taking the, when you are drawing the, or when you are finding the collapse loads. Okay. When diagrams also we have drawn. Right? This type of diagrams we have drawn. Right? 5W by 16 into L by 2, 5WL by 32, that means 2.5WL by 16. VB into L minus WL by 2, you will get 3WL by 16. If the deflection profiles match, this profile, you see that profile same. So directly we can write the moment here, MA. Three into W is 16 into L by is 4 by 16. That's all. So 4 options will be like this. (12 kilonewton meter sagging), because you must be clear whether it is sagging or hogging, like this. So some other options. So 12 kilonewton meter hogging. Like this we should be able to answer. If a hinge is there which does not deflect, this is the way you have to manage the problems. I think we have to reduce the size. Okay? If we, in the exam, the questions will be given such that the deflection profiles are known to us. If not, if the deflection profile is not known to us, you may have to spend say 1 full minute time. Otherwise, 10-15 seconds you can complete MDM problems. Moment at A is like this, right? Now this is a profile which we know from SM. That you can simply attach there. This is your bending moment diagram. Okay, next. Next question. Carryover factor CAB is okay. This point, let us say AB. This point uses C. Okay. Length you can take say L here, L here. This value flexural rigidity you can take say infinity. This is EI directly as is, we can take it. Now like this. Carryover factor you are asked to find, let us say. Carryover factor means ratio of the carryover moment and applied moment. Okay. Now when it comes to this one, A, B, C. Now you have to apply some moment here. Applied moment. Because of this, how much is carried over? MB. If I know how much is the carryover moment, then this divided by this is the carryover factor. It looks this is EI is infinity. EI value is simply L. This length is L. We don't know how to manage. So, but if you draw the deflection profile, that deflection profile looks something like this. Because EI is infinity and it is rigidly connected. If nothing is mentioned means at C it is rigidly connected. If EI is infinity, C point will not deflect, will not rotate. So that means the deflection profile will go something like this. This is a known deflection profile for us. When you apply moment M, carryover moment is M by 2. So we'll manage first this problem. Up to here. See, it is looking like a fixed support. Because slope is 0, deflection is 0. I can idealize as if it is fixed. This is my applied moment M. This is my deflection profile. This point let us say A, C. When you apply moment M, here carryover moment is M by 2. Then the reaction, this is M, M by 2. Total is 1.5 M clockwise. So to balance it here, reaction will develop here VA value 1.5 M by L. Because total clockwise moment is 1.5 M. Couple is will develop like this. This is VC 1.5 M by L. Now this M by 2 is now MC, let us say. Now VC, MC are the reactions exerted by the beam, by the portion CB on the portion CA, like this. Now in return, if I take the free body diagram of CB, that CB portion now looks like this. Here VC is upward, this beam is exerting on this beam upward, in return this will exert downward, like this. VC is 1.5 M by L. This is clockwise, so it will act anti-clockwise. MC is M by 2. These are the reactions coming from this one. This point is C, B. This length is L. Now, to keep this in, this is like a cantilever beam, which is statically determinate beam, because reactions are known to us. So, a cantilever with two loads, VC, MC. Then, since it is a determinate structure, we know how to find VB. Sigma y0 I can write 1.5 m by L down, 1.5 m by L up. So sigma y0 satisfied. Then sigma m 1.5 m by L into L is anticlockwise 1.5 m, anticlockwise 0.5 m. So to balance it, clockwise moment mb is 2m. Now this 2m we call it as carryover moment. Okay. Supposing that if you get doubt how this 2m has come, take moments of all forces about B equated to 0. Clockwise positive, anticlockwise negative. So anticlockwise minus 1.5 m by L into L minus m by 2 plus mb is equal to 0. So mb you will get 2m. Equations of equilibrium are sufficient to find VB MB. Now this is carryover moment we call it, because the reason for developing this reaction is this one, applied moment. So carryover factor means carryover factor CAB. Carryover moment at B by applied moment at A. This is 2m by m. You will get 2. So 2 is the answer. Okay, this is about the carryover factor. Next. What is the value of sinking support C, that is delta, so that VC is equal to 0. Assume that we have applied a load P. Let us say this is a bar. Length is L. L and I. Okay. This problem in one of the GATE papers they have given this L and I value, same value is given, and if C support C sinks down by delta, by how much support C should sink so that the reaction at C is 0. That problem in one of the GATE papers they have asked, that is Li they have given. Supposing that I value is not given, they simply mention that it is a bar. In strength of materials we have studied that once you use the word bar or rod or link or weak beam, the implied meaning is that they cannot take any bending moment. But they can take compression, they can take tension, but not the bending moment. Once you use the word bar, it means that the bending moment in this is 0. It cannot take moment. So even if they ask you, they give you that it is a rigid joint. A rigid joint has no meaning if at all it is if two members, one is so weak. One member is so weak flexurally, means what? Supposing that you have a wall, you take a thread. A thread or cable is rigidly connected to the wall, suppose if they mention, then it has no meaning. Whether you connect rigid connection or a pin connection, it will simply bend. So the rigid connection, once you say rigid joint, will have the angle between the two members will remain same if the flexural rigidities are there, means if they can take the moment. If one of the members cannot take the moment, rigid joint word has no meaning there, which means that once B sinks down by delta, that 90-degree angle will not be maintained. So the implied meaning of bar is that it cannot take. This is the question. Implied meaning of bar is that it cannot take bending moment. It can take tension and compression only. Okay? Now, how it will deflect? Because now that you have understood the meaning of bar, how it will deflect? This point, let us say A, B, C. It will deflect like this. 90-degree angle will not maintain, it simply goes down. Delta. Now you see, this profile is a known profile for us. It is like a cantilever deflection profile. Now we know what is the value PL cube by 3EI. It is deflect. That means if BC rod, if it sinks down by PL cube by 3EI, entire load P is taken by the beam only. This rod simply keeps quiet. It will not take moment, it will not take compression also, because it is going down. Reaction is becoming 0. This is the profile. It becomes now like a straight line. That's all. No 90-degree angle here, though there is no pin, because he used the word bar. Then for this profile we know how to make it. Supposing that if they give you, instead of bar, L, EI is infinity, then we know how to make the deflection profile. Not. What is delta? So that VC is equal to 0. Here this is Li, A, B, C. This is L. Assume that he uses the word EI is equal to infinity. Then what will happen? Then the support is sinking. That means what? This member EI is infinity means it can take moment, but it will not rotate. It simply moves down. Distribution factors, this is 1, this is 0. Distribution factors are. So the deflection profile for this one will go something like this. Okay. Because he has given EI as infinity, the shape of the profile, deflection profile is like this. A, B will come to B dash, C will come to C dash. This we have applied a load P now. For this profile where 90 degrees angle profile was there, we know that value delta is equal to what's the force required? For this profile, this is what we have studied. Okay. For this profile, A, B will go to B dash. This value, let us say delta. See, it is a non-deflection profile for us. This is 6EI delta by L square. 6EI delta by L square. The action that is required is 12EI delta by L cube. Here VA is also this what we know. This profile are matching. Take it, stick it. Then what's the force here? 12A delta by L cube, and that force is P here. Here reaction is 0. That means member BC is not taking compression. Then who will take the load P? Only AB member. So fix it, sink it. For that we require 12A delta by L cube. That means your VB is equal to P is equal to 12EI delta by L cube. So delta you will get PL cube by 12EI. So there are three cases. Depending on the nature of the member BC, your delta can be PL cube by 3A, so that VC will become 0 if it is a bar. If it is a heavy beam, heavy column, if they mention, then it is infinite stiffness, then PL cube by 12EI. If both members of same capacity, then you have studied that point PL cube by 7.5 EI, that we don't have to again repeat that point. The other cases only we are discussing, right? So okay, this is the question. These are the points. So any problems, once they give you the bar word or link or rod, then moment is 0, you can take it, profile becomes like this. Okay, so for this case, answer is PL cube by 3EI. If they mention the word bar, okay, like this. Supposing that if they give this value, say EI value infinity, then this is a profile. PL cube by 12 EI, it will become that value delta. Okay, done with that. So these are the likelihood questions, my dearest. We wish you all the best. I think relatively we have overall view I have given that are likely to come in the exam, in the GATE. In the prelims, again that quick revision, I think I have given you sufficient ideas of how the questions will come on approximate methods of structural analysis. That is not so much important from the GATE point of view. And static and kinematic indeterminacies type structure questions, they stopped asking. Then influence line diagrams, already you are sufficiently familiar. The things that are relatively new means I thought where I can contribute something to your preparation. I think I have given you sufficiently. All the best, my dearest. Good luck.